Electron behaves like a fan. Don't believe me? Let me explain. So for example, we have a fan right here that is revolving and going around, and when we look at it with our own bare eyes, we can see it's simply forming circles, which means it is in all states altogether simultaneously. However, when we capture it with our own cameras, we can only see it in one state at a time. So state 1, state 2, and state 3 differently. Electron behaves similarly. When it doesn't go through the electron detector, it acts like wavy things of all possible positions, all possible states, but when it goes through the detector, we can only detect it as a single particle in a single state. When it comes out, it still behaves like a wave. But you may ask, what is actually waving here? To understand this, we have to come to what is called the wave function, which is simply a math way to describe wave, where a function is we get in an input and we get an output. So let's come back to our fan analogy, and let's say we have mapped out all the possible states of the fan and represented by this wavy graph here. The function works here by putting an input that is a possible state of this fan right here, you get a number. And you take the absolute value of this number and you square it, you get a percentage that says how likely it is to be in that state. And in this case, it is 10%. So there's a 10% chance that we can capture this state at this time. So in actual physics, this input can be everything. It can be the energy of the electron, it can be the angular momentum, it can be the position of the electron at a given time. So in conclusion, it is not actually the electrons that are waving, but it is this abstract information that we can't see that are waving. And that is the probabilities that are waving. And how beautiful is that?